Hi everyone, welcome back. Let's see attributes of a process. Guys, you know already if you take a main memory, it can contain n number of processes can be available at maximum. If you want to identify each and every process uniquely, you need to have an attribute called PID. PID means process ID, which is a kind of unique identification number which is wouldn't to use it to identify every process uniquely. This number will be assigned by operating system at the time of creation of the process. It will be identified, right? So in general, it will be a kind of a number. This is the first one. And the same process can have parent process ID, which is also an unique identification number, which is related to the parent of child process. What I am trying to say here is, if you take here some fork system call, which is used for to create the child process. Am I right? Yes. If I say that it is going to execute and will create the child process. With respect to the child process, this let me take the process name is J, this one is K. With respect to K process, J is the parent process. So in order to identify who is the parent for the K process, this will maintained by the PPID. I can say that parent process ID, that will be J. I can simply say what is the parent process ID for the K means by looking at this particular attribute, I can answer it. J is the parent process. And we can say group identification, right? So which means that for a particular user group who have privileges, they can able to access this process. Means what are the privileges allocated to user groups? They can able to access this process. That is what group identification, which we can call it as group ID. These are all the things which we can in general call it as identification related attributes. Means we can easily identify any process uniquely. If you take something kind of attribute like priority, for each and every process there will be certain priority that will be assigned by operating system at the time of creation, right? Let me take the process P1, process P2, process P3, 4 priority, 1 priority and 6 priority. Assume that low number is having highest priority, which means that what? While executing, P2 will get the highest priority, then P1 will get the highest priority, then P3 will get the highest priority. That is the advantage of a priority. So to identify which process having highest priority, that will be assigned by the priority. This is also kind of a number. And if you look into various states of the process, we can say state. So state is an attribute again. The states can be a new state or ready state or running state, etc., which will clearly define what is the current state of the process, right? So if you are not able to understand what is the meaning of new, ready, running, etc., you will look into this particular part in the next video so that you can get clear idea. Right now you have understood that in the state attribute part, it is going to maintain current state of the process, and it can maintain various kind of list of open files, which means that what are the files that are currently used by the process will be defined by this attribute. Similarly, the process can be connected to device. We can say that list of open devices. What are the currently devices used by the process? So list of open file means currently files used by the process, currently devices used by the process. Okay, there might be some other kind of attributes are there, something like which are related to CPU. I can say CPU related attributes, something like we can say program count, which this contains address of the next instruction to be executed. Address of the next instruction to be executed by the program counter. I mean, if process P1 is under execution and there might be a chance to exit it from the CPU, and again after some time it has got a chance to execute in the CPU, but CPU has to know what are the instructions that it is already executed and from which instruction it has to start execution. That will be maintained by the program counter. Okay, and something like general purpose registers, right? So while executing any kind of a process, it needs certain kind of memory, right? So what are the registers that are currently used by the process will be defined by general purpose registers, and some things which are related to memory. There might be a situation it has to maintain what are the bytes of memory that has allocated to this particular process, and what are the various kind of memory limits that has for this particular process. All it has to maintain by this particular thing. And if you take some other things, it will be like protection, security related, right? So you should not allow to execute all other processes with respect to this particular process, am I right? So something like security related things. So to make security related things, it has to maintain the attribute called protection attribute, and many more are there, guys. These are the main things that you have to remember. Okay, so which means that I am trying to discuss all the things which are related to a particular process, something like process ID, parent process ID, group identification, like that, right? Which means if you take a particular process, this process having all attributes. These all attributes defines characteristics of the process. So by looking into these attributes, I can able to clearly define what are the files that are used by the process by simply looking into the attribute called list of open files. And what are the devices that are currently used by the process? I can simply look into list of open devices. Like that, I can able to clearly answer everything. That is what we need at a single stretch, right? Yes. So in general, these all the things are going to be maintained at one location. We will call the location as PCB, process control block. It is a location where the entire information is going to be maintained. So in other words, if I say PCB is also called as context of the process, I can say what is the present context of the process, like it is in the ready state, or it is in the running state, or I can say it is using so and so file, it is connected to printer, like that. So what is the current context of the process means, we can say that process control block only, right? So let me try to draw the PCB of a process. This is a process control block. In this process control block, it will maintain various things, something like PID, parent process ID, group ID, priority, state, files, devices, etc. Right? Not only like all the things, it contains all kind of attributes. It will be come up with all kind of attributes. Right? So I am just giving an abstract view, guys, not the exact thing. So just make it a note for the sake of your examination. Right? So like that, we are having n number of processes. N number of processes. Each and every process is going to connect it. So this is PCB1 and this is PCB2. These are going to be connected like that. So one process related to one PCB. So I can say that this will be PCB3 and so on and so on. At the initial level, it contains a node. I can say this will be Q, which will be connected to the first PCB. I can say head, and one more thing, it will be connected to last, or if you write in more technical, that will be a tail. It will be connected to the last PCB, and all are going to be connected via linked list. So this particular structure you can understood linked list concept. The reason why they are using the linked list is we can able to easily remove them, we can able to easily add them. That's the reason linked list is using, right? So I can able to traverse from first to last, or I can traverse to the directly end. Okay, so this is the concept of attributes of the process. Hope you understood this video clearly, guys.